What's up, you freaking geniuses? So in this video, I'm going to teach you how to evaluate trig functions without a calculator. And I'm also going to teach you how to write your answer in degree and in radians, all right? So in order to do this, you need to be familiar with two very important triangles. So the first one would be a 30, 60, 90 triangle. And as you can see, it has a relationship, a ratio between the three sides, right? So the shortest side is always going to be equal to x. The other side is going to be equal to x times root 3, and the longest side, the hypotenuse, is always going to be equal to 2x, right? So for instance, if we knew one of the sides, we could figure out all three. So if I told you that x, let's say x was equal to 5, all right? So that means this short side would be equal to 5, this other leg would be equal to 5 root 3, and the hypotenuse would be equal to 2 times 5, which is equal to 10. Now, similarly, we have this special 45, 45, 90 triangle, and the proportions for this one are that the two legs over here are always going to be the same length, and the hypotenuse is always going to be equal to that same length times root 2. All right, so again, if I told you that this leg was 5, that means this leg is also 5, and that the hypotenuse would be 5 root 2. All right, so now let's see how we can use these triangles in order to solve trig functions. All right, so here we have the sine of theta is equal to 1/2. So we're trying to figure out what theta is equal to. All right, so the first thing that you want to refer to here are your basic trig ratios, SOHCAHTOA. Right, so sine of theta is equal to the opposite over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse, and the tangent of theta is equal to the opposite side over the adjacent side. All right, so if we know our three common trig ratios here, we can use it to solve for this trig function, all right? So here we have sine. So again, sine is equal to the opposite side over the hypotenuse, right? So sine of theta, it's equal to 1/2, but we also know it's equal to the opposite side over the hypotenuse, right? The opposite side over the hypotenuse, all right? So what we're trying to figure out here is where does theta go on either of these two triangles to make this ratio true? So we basically have four, well, more like three locations where we could put it, right? So we could either have theta here where this 30 degrees is, we could have it here where the 60 degree is, or we could have it at either one of these two 45-degree angles. Okay, so as you can see, there's four different places where theta can go, but really it's more like three because this one's a 45-degree angle and this one's also a 45-degree angle, so they would both be the exact same anyways. Okay, so for our first one, why don't we start with the 30, 60, 90 triangle, all right? Let's just plug in theta. Let's just say we think theta is there. We're not 100% sure yet, but we think it might be there. And the only thing we have to do is check if these ratios hold true, okay? So if we put theta there, if theta is actually equal to 30 degrees, the opposite side should be equal to 1, and the hypotenuse should be equal to 2. Okay, so if theta really is here, the opposite side should be equal to 1. So what would we have to plug in to x to make this equal to 1? Well, we'd simply have to plug in a 1. All right, so if we're going to plug in a 1 for x, that means we have to plug in a 1 for all the x's, right? And then we can evaluate them. So we'll plug in a 1 there and a 1 right here. So for this side of the triangle, 1 times root 3 is equal to root 3. All right, so that would be the adjacent side, and then the hypotenuse over here would be 2 times 1, which is equal to 2. All right, so for sine of theta, it's equal to 1/2, right? 1 over 2. So again, the opposite side should be equal to 1, and the hypotenuse should be equal to 2. And as you can see here, the opposite side is indeed equal to 1, and the hypotenuse is indeed equal to 2. So that means we plugged in theta in the right spot. Theta is actually equal to 30 degrees, all right? So that means the sine of theta is really the sine of 30 degrees, and that's equal to 1/2, all right? So that's what theta is equal to in degrees. And if you wanted to convert that to radians, you can convert any degrees into radians by simply multiplying by pi over 180, all right? So then here you can see the 30 and the 180, those reduce, right? 3 over 18 reduces down to 1 over 6. So multiplying straight across, we get pi over 6, all right? So there's our answer in degrees and also in radians. All right, now here's the next function we're going to evaluate. So this time we have the cosine of theta is equal to root 2 over 2. So again, we're trying to figure out what theta is equal to. So it's going to be equal to either 30, 60, or 45 degrees. And a little hint here would be, as you can see, we're given root 2. And as you can see, root 2 is part of the 45, 45, 90 triangle. So most likely, theta is going to lie on this triangle, all right? So let's try this triangle first. So again, theta is either going to be at this 45 or this 45. Obviously, they're the same, so it doesn't really matter where we put it. So let's just leave it there, okay? So if theta really is 45 degrees, let's use our trig ratio again. So cosine of theta is supposed to be equal to the adjacent side over the hypotenuse, right? So the cosine of theta is equal to this, root 2 over 2. But again, it's also equal to the adjacent side over the hypotenuse, all right? So if we put our theta right here at this 45 degree angle, let's check the adjacent side and the hypotenuse and see if they're really equal to root 2 and 2, all right? So first of all, the adjacent side would be this side down here. So if we're saying the adjacent side is equal to root 2, in order for this x to be equal to root 2, we simply have to plug in a root 2 right there, right? So again, that means we have to plug in a root 2 over here and also over here, all right? Now, if we simplify what we plugged in, obviously these two sides are equal to root 2, but the hypotenuse, as you can see, is going to be equal to root 2 times root 2, which is equal to just 2. Okay, so here we got that the adjacent side is equal to root 2, like what we're looking for right there. And we also got that the hypotenuse is equal to just 2, right? The hypotenuse should be equal to just 2, which is what we got right there. So that means the cosine of theta is equal to root 2 over 2. So that means theta is actually equal to 45 degrees, right? So the cosine of 45 again is equal to root 2 over 2. And again, to convert this into radians, we can simply take that and multiply it by pi over 180. And then 45 over 180, that actually reduces down to 1 over 4. So then multiplying straight across, we'll get pi over 4. All right, so that's our answers right there. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.